Dear students, in the previous class, we discussed the properties of irrational numbers in the chapter Real Numbers. We have proved that the square root of a prime number is an irrational number, and we have also proved that square root of 2, square root of 3, square root of 5, square root of 7, all these are irrational numbers. We have proved these results by contradiction method. Today we discuss an important problem. Square root of p plus square root of q is an irrational number where p and q are prime numbers. After completion of this property problem, we start logarithm topic. Okay, let us start the lesson now. Class 10, real numbers. Real numbers, exercise 1.4. Exercise 1.4. Students, you can refer page number 16. Page number 16. Prove that square root of p plus square root of q is irrational. Where p and q are primes. P and q are primes. So to prove this result, we will utilize the previous concept, that is when p is a prime number, then square root of p is irrational. We have already proved this result. So we note down this property. If p is a prime, number, then square root of p is irrational. We have already proved this result. Similarly, if q is a prime number, then square root of q is irrational. We will note down these two results. If q is a prime number, then square root of q is irrational. We have already proved these two results. This is only one result. The square root of a prime number is irrational. Now, we have to prove that the sum of square root of p and the square root of q is irrational number. To prove this result, we follow contradiction method. By contradiction method, we assume that the given statement is not true. We assume that the given statement is not true. So we write the first step. We follow we follow contradiction method to prove that square root of p plus square root of q is irrational. Where p and q are prime numbers. P and q are primes. So, by contradiction method, what we have to assume is that square root of p plus square root of q is not irrational. That is, we assume that square root of p plus square root of q is a rational number. We assume that square root of p plus square root of q is a rational number. Is a rational number such that square root of p plus square root of q equal to a by b, where a and b are integers, where the first condition is a and b are integers, b not equal to 0. B not equal to 0. Now the second condition is a and b are co-primes. A and b are co-primes. A and b are co-primes. What is the definition of co-primes? We say that two positive numbers a and b, two positive integers a and b are co-primes if the highest common factor of the two numbers is 1. That is, here we write highest common factor HCF of A and B equal to 1. So this is our assumption. Now based on this assumption, we follow, we develop mathematical argumentation to prove the result. Square root of P plus square root of Q equal to A by B. So now we can write square root of Q equal to A by B minus square root of P. Squaring on both sides. Squaring on both sides. Squaring on both sides. We get to square on both sides, we use the formula x minus y, x minus y whole square equal to x square plus y square minus 2xy. We use this formula to square the above. Therefore, square root of q, square root of q whole square equal to a by b minus square root of p whole square. Now we use the formula x minus y whole square equal to x square plus y square minus 2xy to expand the right hand side term. So left hand side term is q. Square root of q whole square equal to q. This is equal to a by b whole square plus square root of p whole square minus 2 multiplied by a by b multiplied by square root of p. So this is equal to a square by b square plus square root of p whole square. Square root of p whole square is p. P minus 2 multiplied by a by b multiplied by square root of p. So this is on the left hand side we have q. Now multiplying both sides by b square. Multiplying both sides by b square. Multiplying both sides by b square. We get q multiplied by b square equal to equal to a square by b square multiplied by b square plus p multiplied by b square minus minus 2 a by b 2 a by b multiplied by square root of p multiplied by b square. Now from this we get q b square equal to a square a square multiplied by b square gets cancelled, so we get a square only plus b square p minus 2ab square root of p. So we get this. Now we bring square root of p term to the left hand side and qb square to the right hand side. Now we get 2ab square root of p equal to a square plus pb square. So we can write this square root of p equal to a square plus pb square upon 2ab. We can write this. Now from this we will start our mathematical argumentation. We prove that the right hand side term is a rational number. If the right hand side term is a rational number, then we get that the left hand side term square root of p is a rational number. But we know that square root of p is an irrational number. Hence, our assumption is wrong. So now we will continue our mathematical argumentation. A is an integer, p is an integer, and p is a prime. P is a prime. So this implies a square is an integer P is an integer. P is an integer and P square is an integer. So it implies that A square is an integer and the product PB square, PB square is an integer. This is by the property that the product of two integers is again an integer. The product of two integers is again an integer. Here P is an integer, B square is an integer, so PB square is also an integer. Now we apply the property of integers again. The sum of two integers is again an integer. So here A square is an integer, PB square is an integer. Therefore A square plus PB square is also an integer. So we prove this. That is the numerator of the right hand side term is an integer. We prove this result. Now we consider 2ab, the denominator term. So 2 is an integer, a is an integer, b is an integer. This implies that 2ab, the product 2ab is also an integer. Now highest common factor of a and b equal to 1 and b not equal to 0. This implies that a is also not equal to 0. So therefore, here we got that a is not equal to 0, b is not equal to 0. So we have a is not equal to 0, b is not equal to 0 and 2 is not equal to 0. Two is not equal to 0. This implies that 2ab is not equal to 0. So now we got an important result. So the denominator is also an integer and and 2ab is not equal to 0. Therefore, the right hand side term a square plus pb square is an integer, 2ab is an integer and 2ab is not equal to 0. From this we can conclude that a square plus pb square upon 2ab is a rational number. Is a rational number. So if the right hand side term is a rational number, then we can conclude that the left hand side term is also a rational number. So this implies that square root of q is a rational number. Square root of q is a rational number. But with that, square root of q is an irrational number where q is a prime number. But we know that square root of q is an irrational number where q is a prime number. Where q is a prime number. So we got a contradiction. That is, in fact, the square root of q is an irrational number, but we got that it is a rational number. This is a contradiction. So we write we got a contradiction. We got a contradiction to the fact that to the fact that square root of q square root of q is irrational. So why this contradiction has arisen? This is because of our wrong assumption. That is, our assumption that square root of p plus square root of q is a rational number is wrong. Hence, our assumption that square root of p plus square root of q is a rational number is wrong. So if our assumption is wrong, then it is not a rational number. Therefore, square root of p plus square root of q is not a rational number. This is not a rational number. If it is not a rational number, then by the definition of an irrational number, we can say that it is a irrational number. What is the definition of irrational number? A real number, a real number which is not a rational number, which is not a rational which is not a rational number is called an irrational number. Is called an irrational number. Hence, square root of p plus square root of q is an irrational number. Therefore, square root of p plus square root of q is an irrational number. So, hence the result is proved. Hence, the result is proved by contradiction method. Hence, the result is proved. Hence, the result is proved by contradiction method. Dear students, let us discuss this problem.